Hello guys, welcome back to my YouTube channel. This is Dr. Manjunath Chennapugod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we were discussing about syllabus of heat and mass transfer. Dear students, come today we'll move towards next topic on heat and mass transfer. So before starting the syllabus, it's our responsibility to respect the scientists who have invented a lot of innovation towards the development of science and technologies. So let us remember and honor the legacy of the scientific gains who have shaped our world. Their dedication, curiosity and unwavering commitment to innovation have transformed our lives in countless ways. Their work is a testament to the power of the human ingenuity and the potential of science to improve the world. So there are many scientists are there. They have sacrificed their life towards the development of science and technology. Some of the scientists we can name here: James Joule, Joseph Fourier, Prandtl, Reynolds, Isaac Newton and Lord Kelvin. Now we'll move towards next topic, that is thermal science. Before starting heat transfer, this heat transfer is a branch of thermal science. Okay, when it comes to thermal science, it is having three topics here now: thermodynamics, heat transfer, fluid mechanics. We can say thermal science is a combination of thermodynamics, heat transfer, fluid mechanics. So dear students, we know already what is thermodynamics. Thermodynamics is a branch of science, or it is a branch of thermal science which deals with the energy transfer and its effect on the system. That is thermodynamics. And also thermodynamics is going to discuss some laws which are related to energy conservation. That is what thermodynamic. Next, heat transfer. Heat transfer is also a branch of thermal science which deals with the rate of heat transfer and temperature distribution in the system. That is heat transfer. Then next is fluid mechanics. Fluid mechanics is also a branch of thermal science which deals with the behavior or characteristics of the fluid in a system. That is known to be fluid mechanics. How it is, dear students, that you can see here now. I will take one example and I will try to explain what is thermodynamics, what is heat transfer and what is fluid mechanics, that you can see here now. Dear students, I will take in a cook pot. Assume that you can take any fluid is there. So with help of this live example, I will try to understand you what is thermodynamics, heat transfer and fluid mechanics. What is thermodynamics? Thermodynamics, you can see here now. When you are going to switch on the gas stove, right, burner, right, the burner is going to produce some heat. That heat is nothing but what? Energy. So how this thermodynamics is what it is going to deal here now. It is going to, when the heat is going to transfer, right, that because of that heat interaction, the properties of the system, you can call it as a system, right. Already I have explained in thermodynamics what is system, what are the different types of system in detail I have discussed. If you want to know the definition for system, types of system, you can go and refer my videos which are there in thermodynamics playlist. Okay, so now thermodynamic system. Now what happens, when you are going to switch on the burner, right, you are going to supply certain amount of heat to the system. You can call it as a pan. It is having some fluid. You can take water or anything else. When you are going to supply certain amount of heat, right, then what happens, the properties of the system is going to change. If there is a heat interaction, because of that heat interaction, the properties of the system is changed. This concept is discussed under a subject. That subject we can call it as a thermodynamics, or we can call branch of science. We can call it as a thermodynamics. Thermodynamics, what it is doing here now? It is going to discuss on the heat energy interaction and its effect on the properties of the system. That one thing you can take, dear students, now. Second one, heat transfer. Now, how much amount of heat is transferred to the system? Okay, at what rate it is going to transfer, in which way, in which mode the heat is going to transfer. That fundamentals or concepts are well explained by a branch of science. That branch of science we can call it as a heat transfer. So heat transfer, what is heat transfer? Heat transfer is going to discuss how much amount of heat transfer, that is rate of heat transfer. Rate of heat transfer means what? Rate of energy transfer for unit time. You can take small t. But thermodynamics, what it is going to discuss? It is going to discuss about energy and its effect on the system. Okay, it is thermodynamics. Rate of heat transfer is nothing but what? It is going to discuss about the amount of heat transfer for unit time. And also it is going to discuss about the temperature distribution in the system. That is heat transfer. The next, fluid mechanics. Fluid mechanics means nothing but what? You can take, I told you earlier, right? You can take any kind of fluid. You can take water or you can take anything else. If you want to know the properties of that fluid, then fluid mechanics will come into picture. Fluid mechanics, what it is going to do? It is a branch of science. It is going to discuss the properties of the fluid. That fluid may be at under rest or it may be under motion. If you are studying the properties of the fluid, or if you are studying the characteristics or behavior of the fluid, then that branch of science we can call it as a fluid mechanics. That fluid mechanics is what? Again, it's a branch of thermal science, dear students. This is about what? Thermodynamics, heat transfer, fluid mechanics. Okay, now, so what is the foundation of thermal sciences? You can see here now, thermodynamics. What it tells, dear students, as I told, it focuses on the state function and laws which are governed to the energy and entropy. As I told, dear students, energy interaction and some laws they are going to explain about the heat energy exchange. That laws will come under thermodynamics. When, as I told, dear students, the properties of the system. What type of properties? Some properties we can say, or some thermodynamic properties, or some state functions or state variables, they are going to change because of the heat interaction. That properties we are going to study in a branch of science, that is nothing but thermodynamics. What type of state functions or state variables? That is nothing but pressure, volume and temperature we can consider. If we are studying the proper state functions or state variables, pressure, volume and temperature in a system, that branch of science we can call it as a thermodynamics. Then heat transfer. This is a branch of science again. What it is going to do? It is going to deal with the mechanism of heat transfer and laws which are considered for the transfer of heat energy. What is that mechanism? Means what? That heat is transferring. Right now, you can take it in the previous example. Heat, we are telling heat is transferring. In which way it is transferring? Whether it is transferring in conduction or convection or radiation. We know already heat is going to transfer in three ways: conduction, convection and radiation. That I will discuss in detail in upcoming classes. Now, heat is transferring, right? That heat may transfer in three ways: conduction, convection or radiation. So, in what way it is transferring? That heat transfer is going to discuss. And how much amount of heat is getting transferred? That also it is going to discuss. That branch we can call it as a heat transfer. So now, as I told, dear students, thermodynamics, what it is going to discuss? It is going to discuss on the state function. That may be pressure, that may be volume, that may be temperature. And also thermodynamics is going to discuss some thermodynamic laws. We know already what is thermodynamics laws. You can say first law of thermodynamics, that we can call it as law of conservation of energy. Second one, zeroth law of thermodynamics. It tells about the equilibrium of thermal equilibrium. It is going to tell. That is zeroth law of thermodynamics. Then second law of thermodynamics, that is Kelvin or classes we can consider. Okay, next second law. Okay, next third law is also there, but this thermodynamics, what it is going to do? It is going to discuss about the thermodynamic laws. And also the thermodynamics is going to discuss about the equation of state. That is what? PV is equal to nRT we can write, or PV is equal to, if you are considering mass, you can write it here now, PV is equal to mRT. This is what? Equation. This thermodynamics is going to discuss on state functions, thermodynamics laws and equation of state. But when it comes to heat transfer, it is going to discuss, about the modes of heat transfer. Heat is going to, as I told dear students, heat is going to transfer in three ways: conduction, I will write short, conduction, convection and radiation. So this conduction heat transfer well explained by a scientist. That scientist we can call it as a Fourier, and that law we can popularly call it as a Fourier law of conduction. It is going, heat transfer is going to discuss about Fourier's law of conduction. Similarly, Convection heat transfer is well explained by a scientist. The scientist name is Newton. Then that law we can call it as a popularly Newton's law of cooling. That heat transfer is going to discuss about Newton's law of cooling. Similarly, radiation heat transfer well explained by a scientist. That scientist name is Stephen Boltzmann. That law we can call popularly as Stephen Boltzmann law. This law also well discussed in a branch of science, that is nothing but what? Heat transfer. So now we can calculate the rate of heat transfer either in conduction, convection and radiation with the help of different equations. That equations we can call it as a heat equation. So it is about heat transfer. Now, so what are the application of thermodynamics? That you can see, dear students, now thermodynamics and heat transfer. So thermodynamics applications you can see here now. Power generation, refrigeration and air conditioning system, chemical engineering, material science. Next, heat transfer. You can take electronics cooling, heat exchanger design, insulation and aerospace engineering. These are what? Application of heat transfer. That's fine. Then here are some difference between heat transfer and thermodynamics. What is that? You can see here now, dear students. Okay, now here you can see, dear students, it's a thermodynamics and it is a heat transfer. What is the thermodynamics now? What actually it is doing here now? You can see here, dear students. It is going to thermodynamics is a branch of science. Heat transfer is also branch of thermal science. Both are branch of thermal science. But thermodynamics is going to discuss on the system property analysis. As I told, dear students, when you are going to supply certain amount of heat to the system, right? How much energy you have transferred, but you are not calculating that amount of energy transfer per unit time, but you are going to calculate the amount of energy. One thing, because of heat addition, some properties of the system is going to change. That properties you are going to study in thermodynamics. What are the properties? You can call state variables or state functions. That is pressure, volume and temperature. That is first one. But when it comes to heat transfer, it is going to discuss about thermal system design. How much amount of heat is transferred. Based upon that heat transfer, what material is good for thermal system, that we are going to calculate with the help of a heat transfer. That is first difference. Second difference, you can see here, dear students, 1 minute. You can get energy amount. But here when it comes to thermodynamics, we are going to concentrate on only how much amount of energy is transferred from system to the surrounding or surrounding to the system. But when it comes to heat transfer, it is going to tell about how much amount of heat energy is transferred per unit time. So thermodynamics is going to discuss only energy, how much amount of energy came out or how much amount of energy is supplied to the system. We can call it as a system, right? Fine. So now, but when it comes to heat transfer, it is going to discuss amount of heat energy transfer for unit time. That is nothing but what? Heat transfer. That heat transfer is represented by notation Q actually, dear students. What is Q here now? Rate of heat energy transfer for unit time. That is second difference. Then third one, thermodynamics. It is a time independent. But here when we are going to transfer energy from system to the surrounding or surrounding to the system, right, we are not at all considering time actually. We are not at all going to consider the time. Hence we can say thermodynamics is a independent analysis, independent thermal analysis. But here, as I told, dear students, when it comes to heat transfer, right, second one, heat transfer, it's a time dependent. Why? So we are going to calculate rate of amount of heat transfer for unit time. Hence heat transfer is a time dependent. That is what? Third difference. The next, heat transfer. Generally energy transfer we are going to consider. We are telling here now energy is transferred. That heat energy is transferred from system to the surrounding or vice versa. But we are going to tell only heat energy transfer. But we are not telling specifically how that heat is transferred. Whether it is transferred in conduction, convection or radiation. We are not at all discussing in a branch of science. That branch of science is nothing but what? Thermodynamics, dear students. Okay, in thermodynamics just we are taking energy is transferred. That means general energy transfer we are going to consider. But when it comes to heat transfer, we are going to discuss or we are going to deal with the specific heat mechanism. You are telling heat is transferred, right? Heat is transferred. That heat is represented as Q. How it is transferred? Whether it is transferred through conduction or convection or radiation. In detail we are going to study how the heat is transferred, in which mechanism it transferred. That we are going to study it in a branch of science that we can call as a heat transfer. Okay, that is what specific heat mechanism we are using to determine the how the heat is transferred. One thing. Next, uniform system treatment, and it is going to consider spatial variation. And dear students, as I told, thermodynamics we can do analysis when system is at equilibrium condition, but here heat transfer you can use it for even non-equilibrium conditions. Dear students, again thermodynamic equilibrium, that in detail I have discussed in a thermodynamic equilibrium concept videos, you can go and refer. Thermodynamic equilibrium means what? The system should be in equilibrium with what? Mechanical equilibrium, thermal equilibrium, chemical equilibrium. So then only we can say thermodynamic equilibrium. So when it comes to thermodynamic analysis, that system should be in thermodynamic equilibrium. But when it comes to heat transfer, there is no compulsory. That system may be non-equilibrium also. We can do analysis. That we can call as a heat transfer, dear students. This is about heat transfer and thermodynamics. Okay, thank you. We will discuss in next class.